getting over the new functionality, how it works, how the folders are organized, why we are doing it this way, and get your also input and feedback if possible. So it's relatively.
So we're looking for feedback?
Yes, definitely. We are looking for feedback. I mean, either today or next week after you had a chance to try it out and see what things don't work or don't make as much sense as you would like, or things that you would like to have different. But today I'm just going to present the functionality. If anything kind of pops out, that's why are we doing it this way? Wouldn't it be better to do it that way? And anything like that, that's perfectly fine to talk about that today. And then next week, after you had a chance to try out the new scripts and the new functionality, then also you will have a second chance to modify things and say, well, I would prefer this to be this way or something like that, or why don't we add this additional functionality or whatever you think that it makes sense.
Okay.
Are we all in? Are we still waiting for somebody, or should we go ahead and start?
Yeah, Matthias isn't here, but it's 10, almost 10 after, and he's not working with fMRI data right now, so
okay.
I think we could
go ahead and start then.
And
we're recording it too. So yeah.
Yep, and it's being recorded.
Okay, cool. So we'll get ahead and start. Okay, and it's pretty much going over the documentation today. So after you already had a chance to try out the FranKlab scripts before, the FL scripts that we had. And what we've been doing since that last version until now is basically to add a little bit of more of a structure, basically with your feedback and the experience on your experiments of running these scripts. We kind of realized that it might be better to have a little bit more of an organization, or a more rigorous organization as to where to put your configuration files. And having this organization has several advantages. One is that you know where to look for things in somebody else's experiment as well, because now all of the configuration files are going to be in the same place and named kind of like in the same way. So when you're looking at somebody else's experiment, it's very straightforward to interpret what it does. And also the scripts also know basically this organization. So instead of you having to point out where your configuration files are and how are they named, since we are kind of like imposing a structure for that, the scripts already know a lot of more information that they did before. So it's very simple to actually run something. And now it's all you have to do is pretty much say, well, run this subject, and the scripts will know where to look for the configuration files and where to look for the actual data and things like that. So basically it's the same thing that you saw before with the FranKlab FL scripts, but now we have the thing that we call FL Basic, which in addition to the functionality that you saw before, we have some additional structure to it. And the structure basically goes around a particular way of organizing our data, and it's like a folder structure where we're going to be putting our data, raw data, where we're going to be putting configuration files, how are those things are going to be named, and we'll see about all of that. Basically, the organization here in the first section, the data organization section. Then we'll talk about what do you need to do when you define a new study, and basically what files you need to put and where, and what files you need to create, and what information do they contain. And then we'll talk about in this section the running FL Basic scripts section, on how to actually run the scripts to process your data. Basically, it's a very simple, three command line, like single line commands, where you have just one call to importing your data, the processing your data, and then running first level analysis and looking at quality assurance display and things like that. And then we'll show a few examples of configuration files just to show so that you have a few starting points and you have the documentation. We'll show these examples. We won't go into much detail, well, a little bit, but not much detail about the configuration file formats, because it's all documented here, basically the details of all of the different things that you can put into your configuration files to do all sorts of weird things. Okay, so that's pretty much what we're going to talk about today. Do you have any questions before I go ahead and start?
This is shared, right, with everyone?
You are looking at my screen, or you are not?
Yeah. Yeah.
Okay.
Just in general,
the document.
Yeah, this document is shared. This is. I sent you the link. It doesn't have a proper name. It's just this link. I'll share it after the talk again if you didn't get it. But I sent a link to this document. You should be able to edit and comment it as you see fit. Basically, anybody that has the link can edit this document and comment on it. So you can add comments to it if you want, or you can make any changes that you want.
Ultimately, this is the kind of, this will be on the website as a reference. But.
Right. I mean, we are building these things. There are a couple of things that I'm still kind of working on there, and there's things that I expect to change. But this is kind of like working towards having a documentation file that we can put together with our scripts. Basically, it will be kind of like the documentation for our scripts, how to run them. And we are trying to just make it so that it's understandable and that other people in the future also can read this and have all of the information that they need to get started, basically. Okay, so installation, we don't need to worry about that because it's already installed. And there is only one perhaps minor thing that we might want to decide, but this is mostly for the future. For right now, there is one, basically the way this organizes that the data is all going to be placed in one place in our hard drives. And that place currently is called Project MB BUSP Lab FL. In the future, you can change that because basically where the scripts to look at is within the script, the actual software is stored in the project BUSP Lab software FL. This is where the FrankLab scripts are reside, where they live. And within that folder, there is a soft link that is called repository that points to the actual place in our hard drive where we are going to be, in our cluster, basically, where we are going to be storing all of our experiments. And currently, this is pointed to this, but if in the future we decide to change it and point it to someplace else, we can just have to change this soft link to point to some other place, and that will be it. So that's the only thing. Oh, and there is another thing. I also made a couple of changes just to make it a little bit more forceful regarding versioning. So there is this well, you just probably saw it already. There are different subtle differences when you run things like normalization. If you're using one particular release of SPM12 or another, and there are huge differences if you're running SPM8 versus SPM12. So trying to make everything consistent. What I did was basically we are being a little bit heavy-handed perhaps, but I want to get your input on that as well. We are forcing to use one particular version of SPM and one particular release of SPM, and we have a place where we actually define just a text file where we define where that what that SPM release that we want everybody to run is located and which version number and release number it is, so that when you actually try to run FL scripts, it will test for that, and if you are not using the same SPM version as the one that is kind of like mandated, it will complain and it will try to uninstall your version and install this version of SPM. And the reason that we are doing that is for consistency, basically, because it makes our lives, because MATLAB is very flexible, right, and it will allow you to run, and our scripts are also very flexible. They can run from all of the releases of SPM8 and all of the current releases of SPM12, and I imagine that anything in the future should be backwards compatible, so it should also be able to run those. But that flexibility comes at a price, which is basically a replicability of the results are kind of like suffer because of that. So for now, we are basically enforcing one particular version and one particular release so that everybody is using that. And we are trying to make that simple so that the scripts will actually remove the path to your version if that doesn't comply with the current release number that we are enforcing, and try to add the path to SPM to the proper version. And it will do all of that kind of like behind the screen, but it will give you a little message when you run the scripts telling you that your version wasn't quite the one that we want to use, and it switched to the other version. So do you think this is a good idea? Do you think, I mean, this, you don't have to answer right now, but if you have any thoughts about versioning, this is a good place to stop and make a brief stop and talk about that. What do you think?
I think it's a good idea.
Yeah,
I think everybody's going to welcome this reduction in.
Okay, this is a little heavy-handed because it will force you to run that version. If you're not running that version, it will try to run it, and if it fails because of any reason, it will stop and it won't allow you to continue. The good thing is that you are sure that you're running the correct version. When you run the analysis, you are sure that you run the version that you thought that you were running, because many times it happens that you are not totally sure. You thought you were using SPM12, but there was some hidden script that actually used an add path command and changed that for you before you realize. And so I don't know. There are many cases where things get complicated. So this is very heavy-handed. If when you're running or when you're trying it, it feels too heavy-handed and you can come up with better ways to handle it, let me know. I mean, open to suggestions. This is just a way to experimental way to try to force everybody to use the same actual version and release number. And also when we get the new SPM, which we never know when that happens, we will have to sit and decide what to do about that. Would we want to rerun all of our data on a new version? Is it worth it? Is it worth the difference between them? But this basically makes us all a little bit more aware about versioning, particularly with regard to SPM, which is the thing that kind of like affects more the results the most.
Is that just a question? Is that installation page, is that for future use, or is there something that I may have missed something? Do we need to do all this like on the cluster, or should these locations already be there?
The software version, let me see if I have something open here. I don't have, this is, where am I here?
I think what Saul was asking was, you have that page that says installation.
Yeah.
Right, the installation you don't need to worry about, yes, because we already have it installed. This is kind of like if you want to take this and you install it in a different machine, you can, because there is nothing really specific to our particular cluster or anything like that. This will work on pretty much any cluster, and if you don't have a cluster, it will still run on your computer if you run it on your laptop. And you can actually install it on your laptop and run your analysis in there. You just have to specify a different location where the things are going to be stored. So this is a relatively flexible thing that you can install and run on many different machines. But in our particular cluster, you don't need to worry about the installation section because it's already installed. And there are a few files where you have to specify basically that information about which version you want to use and things like that. And that is already all taken care of, so you don't have to worry about that. Okay, so the general FrankLab data organization that we are kind of like trying to push our studies towards is basically this, and this is just a way to organize. It's very similar to what we had before, but it's just a way to organize different experiments and different subjects within each experiment, and basically have a simple way to specify different aspects of each experiment. So for every experiment, you will have a folder that is the experiment name, and this is just in this example I'm going to be using as if I had an experiment that is called is actually example, and then you have subjects within that experiment, and each subject has a subject ID which is composed of the experiment ID plus then a number plus something optional that could define different sessions or different runs or things, well, not really runs, but different aspects of copies of the data or different aspects of that. But basically, subject ID is the experiment ID plus a number. So for example, example 01 is a subject, example 02 will be another subject, and so on. Okay, and within the experiment folder, you have these things. You have code. This doesn't have any particular structure to it. This is just where you would place your own code. If you want to, you create any MATLAB files or anything to run particular analysis, you place it in here for that particular experiment. Then you have to specify a config folder for that experiment, and this is where you place all of the configuration files for that experiment. And the configuration files are the same thing that we talked about already in the FrankLab scripts. You have configuration files for specifying where your actual functional and structural data is, what are the experimental design in your study, what are the contrasts that you care about. All of that information is provided in different configuration files, right? So the way that we organize that is by having this kind of like naming convention for these configuration files. Basically, you will have one configuration file that corresponds to every individual subject, that is called just by the code of the subjects, for example, example 01, and then config CFG, and that basically is where you define the data. What is the source of the data? Where the data that you got from the scanner. You remember the functional and structural tabs. Perhaps we will go over the details a little later, but this is basically where you specify where your data is, your raw data is, and also what is the experimental design, what are the files that encode the experimental design for that particular subject, and what are the different functional runs that you may have run, and if you have things like VDM, volume displacement maps, and things like that, you will also enter them in there. Basically, this is the source of the data and the experimental information, just pointing to the files. And this is the design files. Anything that is called design underscore something is a design information file, and this basically contains information about the different runs that you had in your study. So for every different subjects might have been undergone the same experimental design for individual runs, and so you might have like different types of runs that then you randomize across subjects or across repetitions. And here you specify basically all of those different runs for every individual run, where you have different order of presentation of stimulus and things like that. You specify the design configuration file that specifies that run condition onsets and condition durations and condition names. That is basically the information that you enter in the design for that.
Alfonso, what if for our design for each subject they need a different design config file?
Right, that's a very good. You can specify. You can then simply point different design information. Well, don't have a way to specify the way that is currently done, and you tell me whether we could simplify it perhaps, is that you specify, you don't have any naming convention for that. You can specify design, example of 1A, example of 2B, and because those names of these design configuration files, you have to specify in here, basically. You have to create an example of 01 that says, this is my data, for example, for this subject, and this is the experimental design for this subject. So you have to point to whatever design files you actually comprise the data for that individual subject. So we are not enforcing any particular naming convention for that. You can name it whatever way you find best, and you just have to specify those names inside these files.
Okay,
Does that make
okay,
sense?
thanks.
We do have things for subject-specific preprocessing steps and for subject-specific first-level kind of like design information, well, more like estimation information, but that is different from this. Basically, for the design, we are not imposing any particular naming convention to that. We are allowing you to basically to create any series, because I imagine that we have very different scenarios. We might have subject-specific files in here, but you also might have session-specific things that are repeated across subjects or some, or I don't know. It could get as complex as you want. So trying to enforce a particular naming convention on that felt a little too heavy-handed, but I don't know. Give it a try and let me know. If you prefer to have something that specifies directly the subject information within these files and have the scripts look for that information automatically, we could do that as well. Okay, then we have a preprocessing configuration files, and basically you have different preprocessing pipelines. For each preprocessing pipeline, you will have a file that is called preprocessing underscore and the name of the pipeline, and that contains all of the processing steps. So basically, this is the list of preprocessing steps, like whether you want to run realignment, followed by normalization, followed by correlation, or whatever type of preprocessing steps you want to run. You can create different pipelines, and every pipeline just is associated with a different configuration file. And then you also have potential different first-level analysis. For each first-level analysis, you have to specify basically which contrast you care about. With not just one, many contrasts that you specify, and any things that are specific to that first-level analysis. So, like estimation options. Are you using a high-pass filter? Or are you using a different number of covariates? Are you regressing out art components or not? All of that kind of like design, like first level estimation options, those are specified in these first level configuration files, and they are always named first level underscored and then the name of your particular first level analysis. Okay, and that is all the configuration files that you need, basically. Then and they are all placed in here. Then you have subject-specific folders. They are all called sub dash, and then the code for your subject, which is in this case example of 1. And this follows the BITS convention, except we are adding this scanner folder in here to specify the actual data that you get from the scanner. So basically, this is what everything that is in blue are the things that you have to create when you create a new experiment and when you add a new subjects, and everything in black is anything that is derived from this information by the scripts automatically. So after, so all of that we've seen so far is basically all that you have to create to specify the information for your experiment and for the different subjects and the actual data for your subjects, and then you will have to simply run a few scripts and it will create everything else in here, which is basically for each subject it will create an anatomical and a functional folder that is in this format and contains the actual functional and structural data for that subject with corresponding JSON files if they were coming from DICOMs and things like that. And also field map information is stored in there, and this basically contains the data that is raw for that subject. I mean, beyond any type of preprocessing, so before any type of preprocessing or any type of analysis you don't want that. It's basically the result of just importing your data from the scanner, basically from the scanner files into our database. And once we have it in our database, this will remain constant, and then everything else will come into this derivatives folder. So once you import your data, you will have also derivatives folders for that individual experiment folder, and within each derivative folder, they are all named by preprocessing pipeline. So basically, you can run different preprocessing pipelines on this particular data, and every one of them will have a different folder name. So if you created a pipeline that is called preprocessing underscore M&A space, then you will find an M&A space folder within the derivatives file, and that will contain everything that is derived from this particular pipeline of your data. And within that, you will have also subject folders that contain the actual anatomical and functional data and all of the preprocessing that has occurred on that particular subject. And in addition to all of that, which contains the results of the preprocessing, you will also have results, first-level analysis folders within this, which contain any first-level analysis that you run within that particular preprocessed data that you have. And these basically are the analysis ID, first-level analysis IDs. So if you created something that is called first-level speech, then you will create something will appear here that is called results first-level speech that contains the actual results for that first-level analysis that you define. Okay. Does this make sense so far? At least generally, we'll see in more specific examples how to create these config files and how to enter this data. But just the general organization, do you have any thoughts, any comments, any suggestions?
Alfonso, are the JSON files in the functional, are they optional? So the pipeline can use them, but it doesn't necessarily require
Yes, currently the JSON files are just a product of the DICOM conversion, and they are not used. Well, they could be used, but they are almost not used for anything. So they are created by the DICOM conversion. When you enter your raw data, it creates a JSON files that contain all of the basically most of the information that is in the DICOM headers is split out into these JSON files, just so that you have a very complete information about what that particular data set.
Yeah.
Basically. But then it's not mandatory if these files are actually created by the scripts. If you remove them or you don't want to have them in there, that's perfectly fine as well.
And we have, so that information will be very helpful for doing things like the ENDAR reporting and anything equivalent to that, where we just want to have a bunch of information about the scans. So for the functional scans, will there be any text file that will be stored in that sub-example 01 functional directory that will have information about the task, the study design in there, or would we just be pulling that from?
Right. Currently, no. That information is being pulled from these configuration files. I have the option, but I'm unsure what to do about that. I could very easily convert this into TSV files that follow the BITS convention and that contain the information for that design. But that will make basically redundant, and it will make it unclear which one is not. Well, currently we only have that design information in these files, and that makes it very simple. Basically, when you change this and you run first level analysis or something like that, then it will use that information. But if we have also, in addition to these TSV files, we might create a confusing scenario where people are not sure whether by changing the TSV file something will change, or whether by changing these files something will change. So I'm not entirely sure what to do about that. What do you think?
I get that we don't want to do that, where you might change something somewhere, but that's not the place where the pipeline's going to be looking for it. But what would be handy to have is something
just as an output, in the same way as the JSON files that are just used as output, right? So
or just something where so it's very easy for you to say, like, okay, I'm going to ship off this subject's data. I'm going to ship just the raw unpacked volumes and the information that someone would need to know to analyze it, and that would be the information about the acquisition and information about the task, like what onset of different trials. So we had just some way.
Right, I see what you mean. Yeah, if we are kind of like packing this for distribution, we are missing experimental information. Yeah, right. Okay, that's a good point. Okay, I'll add basically the TSV files to these folders, which can be created automatically by this. Only that, well, I'll just try to make it clear in the documentation that those TSV files are just used as output. They are never used by.
Is that common that you guys have to do that? Or?
I think that we are, well, internally this would be very handy. So, yes, you can do this, right? You can run something. It doesn't have to be part of the pipeline, but you want. So let's say we're trying to figure out what's going on with the SEQ PDS thing. We don't know if, Matt had to spend a bunch of time trying to figure out what files were the right ones. Well, what would be nice is that if in the pipeline that became very easy. So it'll be in there. So it'll be in design_A, right? But then you would want to know for that subject, which ones.
No, I totally get that. I'm just wondering, Alfonso, if there's some way, what do you guys think about making it like an option to add? Because it just feels like, because the redundancy that you're talking about does feel a little worrying if we're going to have it in multiple places. But if you clearly need it, when you do it, you can just turn it on.
All right, I can. That's a good idea. That's a good point.
Right.
You can make it a non-default option that you can just specify when you import your data. You can specify, I want to import it with importing the design information as well, and it will create the TSV files for you. By default, I will make it so that it's not so to avoid the potential confusion of having redundant information about the design there. Does it make sense?
Yeah.
Is it reasonable, the compromise? What do you think, Jason?
Sure. I'll just, once you make it so that you can do this, I'll just insist that everybody always has that.
Okay. Then we'll just have to change the default setting.
I mean, how does that information? We just need to create that information, and then it gets combined with whatever the designs are here. Because I mean, like what the task is not really inherent to any of these other configuration files.
Well, there's what the task is, right? So
Right.
we're studying how the brain response changes when you learn new consonant clusters.
Yeah.
That sort of thing.
Yeah.
You know, and we have the subjects go in and they do this.
Yep.
That information we also want to have. Like there should be in here under, say, example, in here, I think we have we talked about having like a README file or something like that.
Yeah.
That's information about the study, right? But then you have, so it's really like, it's all in here. Like the configuration files are going to say something about, we have these volumes, right? Like in a functional run.
Yep.
We know that at some time point, or if it's sparse, like matching a specific volume, that it's this condition, and this condition, and this condition, and this condition. And it's not just for like NDAR reporting. I think so we in general, we're going toward data sharing, but the way we have this, major effort in doing pooled analysis, right? So internally, assuming that people aren't here forever.
Well, internally, we have all this design information. I mean, this is what we are. There are, I don't know. We could also accept TSV file. I mean, there are.
Well, I don't care about it, like accepting it as part of I don't care about the pipeline relying on these files to operate. But what I would like is that we have. It's very, very easy for somebody to come in and I say, hey, well, why don't you work on this, or why don't you go through this example? And they have a very easy way to access all of this information.
Right, but why do you think that having that information in here rather than having it as a TSV file in here will help somebody new understand what is going on?
I was wondering whether it could just be a utility line that you could run in MATLAB and say, export that information for me. And that would mean that every time you actually export it, it would take care of all the changes that may have happened in the meantime, because some of the functional specification may change. You discover that error with the dummy scans, you would change it. And that would make sure that when you look at it, it's always up to date.
Sure, but I mean, a lot of this information isn't going to change, right? Unless you found out you made a mistake. So you would have to rerun things, and things would over. I mean, in terms of when. So do we have it as when you hit go on FL Basic and you set this stuff up? Sure, I would sort of vote for that, but. Instead, do you have some sort of thing that says, okay, I want to find this information, run MATLAB, it just compiles the information that you need.
But what I'm not totally getting is this why. So the way that we have it right now, I mean, this is all flexible, right? I'm not married to this particular structure, but the way we have it defined is that if any experimental information, you enter into these design files, basically. And you're saying, well, we could also have things in here that look like sub, example, or one, run, whatever, and the TSV files and follow bits format and contain the design information for this particular subject and run.
Well, it's really,
do you think this is better and I should get rid of this? Do you think this is really, why do you think this is simpler, basically, or better?
Well, I guess I originally was asking a question of how direct is that information leak? How directly can you pull that? So if you have let's say you have 4 different config files, and you have an example 01 through however many subjects you have, they're pointing to the config files, So,
for a given subject, so let's say I want to know this particular, right? So this particular subject, I want to know his design. I will look into this example of one file. Let me just, go ahead and show you a few examples then. Okay, the example of one file looks like that. It's saying, well, this is my functional data, this is my structural data, and I have 4 runs, and they have these particular designs. This is what the example of one configuration file tells you. And then you know that the first run, that is basically this, contains this particular design. The second contains, which is this, contains this design, and so on. And then you can go into these design files, which are basically something like this. Let's see if I have like this, and tell you what is happening in that run. It's design A. Basically, you have these onsets and duration and these particular conditions. This is all that you need to know. And design B is going to be looking like something like that. That's what you need to do basically if you want to know what is this particular design for one particular subject run manually, basically. Do you think I could simplify this somehow?
So all that information is there, and we can leave it like this. It seems to me that if you wanted to, so this is a recency effect, but one that's been building for a long time, where I use Matt's example again, where we meet and it's like, okay, what's going on here with this study? And that's that's like a question that anybody would have that didn't originally run the study, right? So not just we're doing it for the purpose of actually trying to freaking analyze the study, the data, but somebody else might just want to understand something about the study. So what Matt would have to do is to satisfy what I felt we needed to have, which was a file that had trial volume number 1 through 40, trial ID like 1, 2, or condition ID 1, 2, 0 through 3. The name, the thing that was presented, all this stuff. So we can post-process run that stuff. And all that is all stuff that you would want, like when reporting to some of these other databases. It's like to the Endar database.
Mm-hmm.
So we can run that after. It's just that in the bid. And the reason I bring it up about being in there is that BIDS format, which is a lot of people put a lot of time into, has those. It has. I don't know everything that's in them. So if we can just derive them, right, so that you can just say, like, here's this series, and here's the information that you need to know about that. Those two things together. All that information is in here, but in order to compile it, there's another step, right? And we can do that step. We can do that after we run the stuff, and we can even figure out how handy that, how necessary it is. Maybe it's not as necessary as I think it is now. So I don't want to hold this up anymore with that. But that's what we would get from it. It's just a file that tells you everything you need to know about that scan.
Okay, everything you need to know is questionable, right? Because there are some additional information that we are entering into this design information that is not relative. It's more complicated to put it into the BIDS format. But we'll talk about that later. Basically, how to basically export this into BIDS format if you prefer to have it like that. It should be relatively simple to export it. It would be possible, not simple, but possible to actually import that information as well if you prefer to specify that information instead of using these config files using BIDS format. It just should be doable as well.
Ultimately, I don't care a whole lot about the BIDS format specifically. It's just that there's sort of an exemplar of having this information easily accessed. So like if we had that.
Well, currently we're trying, I like BIDS as much as everybody else. The idea here is that all of the information is basically in here. A config file tells you everything that you need to know about your data. All of these config files. I could mix it with BIDS and make sure that some information is in config files and some information is in BIDS files, but I don't think that will simplify things at all. I think that will make it more complex.
But we're not really talking about the same goal here. The format part, I don't care.
Right. I could very easily make it as an output, right? And so something like that. That as a process of exporting the data, you will have something like that. If that is all that you want, that's perfectly fine. I can do that.
No. I think it's a bad connection. Saul wants to go ahead.
So it sounds like, Jason, what you want is something that goes beyond, that has even more information than what's in the design files, because
Like the names
Like-
and stuff.
like stimuli, like
Exactly. Well, yeah,
the exact
that's-
stimuli.
Because that's not there.
Yeah,
Well, right.
yeah.
Well, so my original question
Right.
was, we would like to have all this information about it.
Yeah.
Is it in the design? Is it in there already? And if it's so, even if it was in there, but you had to go like I have to go to this file and I have to go to
You're
and I have
saying
to match
both
with this and this.
summarized and more information. That may be a bigger conversation. So
Right.
ideally, you want it all summarized. You can open one document and look at everything in that subject.
Yeah.
But additionally,
Right.
you want potentially all of the other information that's not in here. So
I want everything. in there.
Yeah.
So basically,
Shut that off.
Security,
Yeah.
blood test.
So maybe we should come back to that.
So
Because
basi-
Let's come
Yeah.
back.
that's not going to be answered
Okay.
right now.
so I think basically it would be a MATLAB function that would pull that data from the
I think
various
there's a
text
limit.
files. but
And create some type of report, right, with all of the information that you want. That's, well, yeah. Let me know what is kind of like what is the goal of the report, so that we can try to figure out where to pull that information, and we can very easily define. I mean, right now there is, it depends what information you want to put in there, whether it's all experimental information, what is data about the acquisition, or what is data about the way you actually process it or not, but yes, we can create any type of.
I'm not going to talk anymore. On the next thing.
Okay. So for now, I'll just leave this TSV here. I don't know if I'll make it optional or not, and then we'll think about potential ways of summarizing all of this information. Basically, if you have all of this information here, how to create a summary report that tells you everything that you need to know in a human readable format, or something that you can actually send to somebody else with. It will make sense. Currently, we are not enforcing that you put all of the information that you want in here. You can enter as much detail as you want. You could create design files that contain actual information about the experimental individual trials that you have, or you might enter design files that only contain information about the conditions without going into details about the specific trials. So I don't know, perhaps we could go and try to go beyond what we have right now and try to have a way to specify all of the detailed information about every individual trial, and then have different ways to summarize that. But that is kind of like beyond what we have right now. Right now, in terms of how you specify the design, you have to decide which things are your conditions, and then you just model those conditions and specify whether you want to model them as an event-related design or a block design and that type of information. But we don't have any convention for how to do that, basically. Whether you want to go all the way to trial specific information and then summarize it into conditions, or starting with conditions directly, like summary conditions.
Okay, and I'll just throw in one other thing and break my vow to not talking about this. So where I'm thinking down the road in the very near future is that we talked about labeling the trials for use with like MVPA analysis,
Right.
or some of the other types of analyses. It's where would that go?
Right. There is I mean, you could specify the individual events if you want separately as different conditions, but if you want to kind of like mechanize that, because you just have to, you want to create a condition that has, I don't know, 20 repetitions, but then you want to have the scripts automatically break that down into 20 trials and model each trial specifically, then you have a condition in this basically file. In this file, you can specify that you want to get trial level information that breaks down whatever information about the conditions that you have defined in here. And alternatively, you could specify explicitly the different event information if you want in here. So those are the two options. I'll go about that in a second when we talk about the information about these config files. So before getting into that detail, this is mostly about the structure and the folder structure and organization, where to put things, where, and things like that. I'll go into the details of what all of this means.
So Alfonso, so the stuff in blue is stuff that we do.
Right, exactly. Stuff in blue is what you enter. Basically, when you have a new experiment and a new subject that you want to enter into our pipeline and to our database, how do you do that? And basically, you create these config files to specify the information for that experiment and for that subject, and then you enter the actual data from the scanner, and then you run a few scripts, and it will create everything else in black.
So I guess the one thing that I'm missing, and maybe it's because I don't completely understand format of DICOM files, is so we just put all of the DICOMs in that folder called scanner, and then it pulls out which ones are.
Right. Because in the example of one, if you say you can specify, let me see if I have more examples of that. If not, I can just talk about that. In this, well, what is it? Here it should be. So in this file, you specify where is your data. If you have DICOMs, you can specify here which ones are the DICOMs that correspond to each functional run, and these are relative to that folder. So if you can divide it if you want into subfolders. So for example, if you have a number of DICOMs and you already know which ones are your functional data and your structural data, you could say something like this. I mean, for DICOMs, I don't know, this is a reasonable thing to do. So something like that. Let's say that you created already DICOM files and put it into a func folder within the scanner subfolder, and you specify that your functionals, that your DICOMs are that. Basically, that will import your DICOMs from that particular location. Whatever variable number of runs you have entered into that folder. If you prefer to specify them manually, you can also do that. You can specify, well, something like that, whatever name, complicated name for the DICOM is within that folder. So you, in this place, in the example of one, is where you specify where in particular within that folder, within the scanner folder, is your data, and which is your functional data, and which one is your structural data, and which one is your unwarping, like VDM files, if appropriate, and things like that. Does it make sense?
I think so. So if we have all of that information, sorry, I'm not sure if you're going to get to this, but when the DICOMs are unpacked, well, first of all, does the script do that, or do we do that first?
This assumes that you already have DCM files. I don't know what you probably.
So then do we point somewhere to the summary sheet that indicates how those complicated DICOM string numbers match up with the run numbers?
Right. No, those are automatically. Well, let me look at your data. How is it? It depends. I mean, every machine has a different format for how to output the file. So let me know how. I'll sit with you to look at the raw DICOMs that you have and how they come before unpacking, and I'll see if I can make it a little bit simpler in how we import that data. Because currently you expect to already know which DICOMs correspond to which particular DICOM runs are the ones that you care about, and that information is in these directory folders in the DICOM kind of like. Previous to unpacking version of the data. So I'll sit with you to go over that in more detail, to look at the DICOM information in more detail. In general, the idea is that you put. I'll try to make it as simple as possible for the data that we get from our VU scanning site. So depending on what format they output, I'll try to make it as simple as possible. So you can just point to the directory file or something like that, and then specify which particular runs you have. Currently, you have to specify if you are entering the data in Nifty format, you just specify the one Nifty file per session or per run. Sorry. For functionals, and the same thing for structurals. And if you have DICOM files, you have to specify the DCM files already for whatever DICOM run. But you already have to know which ones are your functional runs. And well, you could import everything if you want. Let me see, and that information will come up in the log file. Yeah, there is a way to just import everything and from the DICOMs and convert everything to Nifty, and then break that into 2 steps, and then figure out after reading the information file that comes from that conversion figure out which one is your functional data and your structural data, and then entering that information into the example of one file. So
I think that's what I do now, but that doesn't mean that's the best way. So I'm open to whatever you think is the best way.
Right.
I'll sit with you to see what is the process, what it needs to be done right now, and we'll try to come up with ways to make it simpler for us.
Awesome,
And we would definitely like to have a unified way of doing this.
Yeah.
And so just to go like this, the unpacking everything, or what you want to call it, importing, basically unpacking all the DICOM information has an advantage in that you see everything's there. Everything is there somewhere for you to be aware of.
Yeah, no, I think
right?
that's great.
So
So then it's just about
there
how
is
to
another
point
way to
to
do
that,
it where
yeah.
you point to specific files.
Oh, yeah.
But the trouble with that is then if someone later comes along, you're not really 100% sure if all of the data have been packed.
No, I totally get that. I think that makes sense. Just not sure how to point to whatever the info file is after it's unpacked to indicate what it is. So yeah, that'd be great. Sit down and talk.
And it might lead to multiple copies of the data in different modalities. You have diffusion data, and that's imported there, that's sitting somewhere. Someone else is running diffusion pipelines, exporting everything, and we've got multiple copies in the cluster.
Right. Well, ultimately, the hope here is that, so DTI is not there.
Right. Ultimately, we will have like DWI files in here, and we will have everything kind of like imported in here.
So that and unpack, everything's there, and then down the road, if you want to make if we need to have a copy for wherever of all the unpacked raw data. There it is. It's in those subject directories.
From what I understand, what Dustin was talking about, I feel he's trying to implement bids so that data would come out as nifties.
Right, exactly. And I try to make this flexible for that as well. So basically, in the scanner folder, you can actually input bits format the data files, and you can import that into our pipeline as well if you want. So I'm trying to make it as flexible as possible, this import, because I'm taking into consideration that somebody else is going to do better than we are doing this DICOM to nifty conversion or more. So at some point in the future, that might change how we are actually doing it, and we might want to use a different pipeline for that step. So this step is rather flexible. You can enter, right now you can enter DICOM files, but you can also enter nifty files directly and very easily import that information into our pipeline as well. So yeah, in the future this might change. Right now we have an in-house way of doing the DICOM conversion if you want to use it, but if you want to use it something else, or if at some point the people, Dustin will implement a better way to have that information converted into bits already directly, we will have basically all of that. Whatever we get from the scanner, you put it in here, and I'll make sure that we can read that information into our structure.
Cool.
Okay. Okay, so that's basically the organization of the folders. Then what do you do basically in detail when you actually go and define a new study? This is the question that you were asking already before, but I'll go into the specific details. What you have to do is basically define all of the things that are in blue here, right? You first define the name of your experiment. When you are starting a new experiment, define the name, for example, ACE, and then create a folder ACE within that repository folder where everything is going to be created. Then you enter the design information files within this location of that experiment, ACE config, create the design information files. This is where you put things like onset, condition onsets, condition duration, some of that information, what happened in the different runs. If you have that information for each subject separately, then you put it like that. If you have a number of predefined experimental runs that you have created for your experiment, then you create a different file for each experimental run. Then you enter also a configuration files for the preprocessing pipelines, whatever pipelines that you think that you might want to use. Of course, you can change that in the future and apply a different pipeline, but basically you create the pipeline, preprocessing pipeline that you want to apply to your data and put it into the config file as well. And we have an array of example pipelines that you can just copy and paste, or you can modify one to your needs. And then you also enter a first level models that specify speech first level model estimation parameter configuration options and things like contrast of interest that you care about, and all of that information. You create a first level underscore model name, one for every type of model that you might want to estimate from your data, or run a different model estimation from your data. And you put that also in the config files for that. For that experiment. And once you have created that, you can start entering subjects, and for entering a new subject, all you have to do is basically put the data from the scanner in here in the scanner folder, and you can have it organized by subfolders in any way that you see fit, or you can just dump all of it in there. Whatever you find simpler to do. After you do that, you basically have to create an ACE a configuration file for that subject that tells where did you put the data, where is the data, what is your functional data, and which one of the data that you put in the scanner folder is your structural data, and any additional information like whether you have warping files and things like that. You enter that. And also, what is the actual configuration, experimental design for this particular subject for whatever number of functional runs you have entered. So if you are saying here in this file that you entered, you have 2 functional runs that you place in whatever place in the scanner folder, you have to specify 2 design information files that contain the design for those actual runs. And you put that into the ACE01 configuration file. And once you have done that, there is nothing else to do. Then you run a few scripts, and I'll talk about those in a second, that will actually import your data into these folders, import all of your data, and then run the preprocessing pipeline and create all of these folders with the preprocessed data. And if you have created also first level analysis, you can also create these first level analysis subfolders with the results of those analyses. So basically, this is what you do for a new experiment when you start a new experiment. And this is what you do for every subject that you add to one experiment. Does it make sense?
Yeah, do you need a config file anywhere that says how to create the VDM?
Right, we don't have that yet. If you have a VDM, you're expected to create that manually. In the near future, I will have that. I want to sit with you to see how you do it in the top-ups, to see if I can incorporate. I know how to do it in SPM, but we are not using that SPM, the phase, like the two phases that SPM does to create the VDM file. So that's not of particular relevance to us. For the way that you have it, I think you need to use top-ups. So I need to sit with you to see if I can figure out how to import that simply into our pipeline, basically.
Okay, so for the moment, for that FMAP,
for the moment, you specify something like this. You specify that the VDM file, you put it in the scanner files, and then you specify here where you specify functionals and structurals. You also specify an unwarp functional field that specify which one is your VDM file for for each run or for every run.
Does it, in order for this to work, Alfonso, do we need to run one of these DICOM reader? So, like for a lot of the DICOM unpack functions, it's a two-step process where one, you run it and it creates a file that has information about each, like pointing to each of the runs or series. Would you need to run that first? Would it make sense to just add that as part of this so that you can...
Right. That's why I wanted to sit with Liz to see if I can see what is the format that we are getting from the scanner. Because right now all that is actually implemented is the second part of that. You already are supposed to know which one of your DICOM runs are your functional data and which one of your DICOM runs are your structural data, and then you just point to that, and this will do the DICOM to NIfTI conversion. But you already need to know that information, and you don't know that information unless you run this first step thing in many cases, because it's not obvious from the DICOM run numbers which one are the actual different data sets. So there is one way to do it right now, which is just import everything. You say import every DICOM, and it will create a log file that tells you basically what its particular run was, and then from that information you can figure out which one was your actual functional runs and which one were something else. But well, I'll sit with Liz to see if we can make it simpler for everybody. Okay, so anybody else about this, about how the information that you need to enter for a new study, a new subject? Okay, so then once you have created these configuration files, then you need to run these scripts, and the format of the scripts, they are basically they are all called FL Basic, and you have three steps that you can run. You can something that is called import, and then you have something that is called preprocessing, and then something that is called first level. So all of the previous version of FL scripts still work. The advantage of using FL Basic instead of FL scripts is that you don't need to, since we are already specifying where your configuration files are located and how they are named, you don't need to actually enter that information automatically. So FL Basic already know all that. So you can just say FL Basic import example01, and it will go ahead and look for this example01 configuration file inside the config folder, and it will import that information, and it will create all that for you without having to specify. You could do the same thing running, for example, this FL command. If you remember the FL syntax before, you could use, this is actually new because it creates something else, but it's very similar. There is for every FL Basic command, there's an equivalent FL command that looks basically more complicated, that does the same thing. And the only advantage of using FL Basic over using FL is basically that you don't need to specify every time where your configuration files are located, because that FL Basic already knows, or where how the data folders are going to be named, because again, FL Basic already knows that folder structure that we're imposing. So basically, for importing your data, you just run FL Basic import and then the subject ID, and that will create this version of this subfolders, basically all of that from your data. You basically import all of that you got from the scanner and put it into this bits format compatible repository for like single sample of your data for that subject, and everything that you run afterwards, like any preprocessing steps that you run, is like a branch from this kind of like source data. This is the main data that you import from the scanner, the first version of the data that you have, and then everything else is going to branch out from this, basically. Okay, and this is FL import. We'll look at the details of the example01 config file in a second. But just the syntax is very simple. It's just FL basic, import on the subject ID. And then if you want to preprocess your data, all you have to do is specify use FL basic preprocessing and then the subject ID, in this case example01, and then the pipeline ID, in this case M&A space. And this will already kind of look for the preprocessing pipeline that is already it should be located in this folder, in the config preprocessing underscore whatever pipeline ID you are using. You will look for that config file to tell him what this pipeline is about, and it will also look at the information in these folders, which are the ones that are created by the step one. When you import your data, it creates this sub example1, example2, so on folders. So those are the ones that the preprocessing need. They are gonna take the raw data from these folders, and it's going to create a copy of that into these folders, M&A sub-example folders, and it's going to preprocess this data in here. So it's going to, anything that is in here, you're going to, all of the outputs of preprocessing are going to be stored in this subfolder. Okay. Does it make sense? And again, the information that it needs for running preprocessing is going to be reading it from the configuration file. So if you already are supposed to have created this configuration file that tells basically this step what this M&A space pipeline is all about, and the format for that we'll see in a minute. And the last thing that you run is a FL basic first level analysis. When you already preprocess your data, well, import it and preprocess your data, you can run first level analysis. And for that, you need to specify three things, which is the subject ID, the subject that you want to analyze, what is the pipeline that you want to use as source for your functional data, and what is the first level analysis that you want to estimate from that data. And that, again, will already know where to look for the appropriate information. For example, when you say something that you want to run the first level analysis that is called speech, you will look for the config files that are named first level underscore speech, right, inside your config folders. And the same thing for M&A. So if you are telling FL Basic that you want to run the analysis on the M&A space pipeline, it's basically going to look at this particular folder, right, because it's the one that contains the M&A space pipeline preprocessed data.
Is M&I space the same as the M&I space that you called the preprocessing?
Right. Anything that I put in bold in here is like a key word that is related to all of these configuration files that we created. So basically, when you create a configuration file, you call it, and for a pipeline, you call it preprocessing underscore something. And that something is going to be the pipeline ID. And okay, that something is going to be matched in here, basically. So it's going to create a different folder for every pipeline that you create. And those are the keys that you have to enter into FL Basic. So when you say, I want to run this pipeline, you enter that thing in bold, basically that pipeline ID, right? So you have something that is a subject ID, something that is a pipeline ID, and something that is a first level analysis ID. Subject ID is this example01. In this example, pipeline ID is this M&A space, and first level analysis ID is this speech thing. All of these are flexible. You can name it whatever way you want, right? You can give it a different name to your pipeline. Only that if you want to create a new pipeline that is called subject space, for example, then you will create a preprocessing underscore subject space config file. And when you run the analysis and ask it to run, then you will run FL Basic preprocess subject example01 subject space, and it will create a new folder that is inside derivatives that is called subject space that contains your data that is preprocessed using this pipeline. The information is of that pipeline is stored in the preprocessing underscore subject space config file. Does that make sense?
Yes, thank you.
Cool. So yeah, these things in bold are not arbitrary. I try to be consistent of putting in bold anything that is a keyword and that matches across different places. So it matches across different folders. If something is called speech here, then it will be created as a folder that is named speech in here. If something is called M&A space here, there will be a folder that is created is named M&A space in here. And the same thing applies for the keys in here. If you are entering something that is example01, that should be something that matches a config file that you created in here, and something that matches, well, sub example01, this should have a bold So I'm sorry about that. That is where you put your scanner data, and also you will have a folder that has that subject ID in here, and all of these things are automatically created by the scripts. Okay. Okay, and the same thing for first level analysis, and that there is always like an FL equivalent command for this FL basic, but it's just more complex because you have to, if you remember, for FL basic, you have to specify, well, what was the design info file, and the design info file was this first level speech config file that the scripts already know where to look for it. So that's why FL basic simplifies things, because this convention of how to name and where to store all of the configuration files, all of your data, makes it much simpler to just call the scripts. So you just have to specify the keys for everything. What is the key, the subject ID, and what is the pipeline ID, and what is the experiment ID, and you will know where to look for the appropriate data and where to look for the appropriate config files. Okay, so
I know that there's some language for the FL pipeline that you've given me before about essentially read every subject in this folder and then do the pipeline for all of it. Would you mind sticking that on here somewhere? Because
I have something in here that basically you can actually, I'll try to make it a little bit more flexible, but you have these multiple subjects commands that you can use. You can use for importing every subject that is called example something. You can, if you want to specify a subset of them, you can use this command to enter, just list them as a cell array, basically, the actual different subjects that you want to import. And the same thing applies for preprocessing. You can use like asterisk keywords for multiple subjects for preprocessing, or you can just use list arrays for running multiple preprocessing steps on multiple subjects. And the same thing for first level analysis.
That's super easy. Thank you.
And yeah, if you run into some, I don't know, there might be some additional things that I will add into the future. Perhaps I'll add like an override option so that you can specify import everything that is not already in there or something like that. That doesn't exist yet, but I probably add something like that in the future.
Alfonso, how does the subject naming now work? So is it always example 1 to 10, or, you know, because for 8, your subject naming is
Subject naming is specified in here, basically. With subject ID, it has 2 or 3 parts. One of them, the first part of that is always the experiment ID. So let me see. So you have an experiment ID part of the experiment. In this case, is example. We are calling example our experiment. So every subject should start with example. Then it should be followed by a number, which specifies the number of that subject, and then it can be followed by any arbitrary string that you want. And that is basically to accommodate things like multiple sessions. If you have like a longitudinal study and you have example like subject 1 pre and post intervention or something like that, then you might use something like example 1-pre and example 1-post to specify like 2 sessions for that same subject. So that is the format for the, and so if you have something that is called ACE, for example, for an ACE experiment, you will call ACE01, ACE02, ACE03, because we don't have multiple runs or anything like that. And it doesn't have to have like O1, it doesn't have to be 0-parity. That is just fine. It will read I think it will read the proper sort anyway, sort them appropriately anyway. So, but it should always start with a number. So it should be always a experiment code, then a number, and then anything else. Do you think this accommodates every scenario that you can think of, or there is some cases where this might not fit what we need?
Well, there are some studies right now where rather than having like a number, each subject is given a unique number, there are things like study code, and then some like P, or like patient, or 01, M for male, 01, and then there's some grouping things, which
because mine switched halfway through, so I had AceCon and then ASD, and then they renamed everything. So I just call everything ACE.
Like the rhythm study, right?
Wow.
Yes,
rhythm study.
like
Rhythm study is like MRI, ANS, MO2.
MO2 and FO2.
But yeah.
But you can add those on the end. So you can
and these numbers only refer to what's generated by the pipeline, right? It doesn't really care whether your Nifty is going in have different names or something like that. This is just the
yeah, but you don't want to make it arbitrary.
Right, these are subject
Yeah,
IDs basically these are subject IDs for the I mean everything will be named so following the subject ID. So basically, yes, I mean when the pipeline creates these format files, they will all contain the subject ID as that portion of that, whatever you specify the subject ID to.
Doesn't matter what it's actually. Yeah.
We don't really want control versus, right?
Right.
Discussion.
We don't.
We don't want that.
It's
So
about, yeah.
We'd prefer that I prefer, and I think we decided that we don't, as a group, don't want that information in there now.
Right, that's
Forward. But so one of the things that you could do,
Yeah.
if it is like that in the past, is you have. No, I guess it wouldn't work that way, right, Alfonso? So if you, because you're looking for some consistent ID and a number, so you'd have to do something like. You'd have to do like something.
But this can be followed by something else. So you could call it, I don't know, ACE, O1, and then group something.
MRI, blah, 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 blah.
Oh, okay.
That'd be one way to do it.
So I'd have to sort of rename each of the subjects for this. As in make it RHY01 underscore whatever they were originally called.
Right, and why do we want to keep how they were originally called? Sorry about that.
Just for ease and consistency for what it's all been labeled as, because I don't know. I think it's easier because everything is now in that all the data collected in this study is in that format. I could just associate each one of them with a new number, but because we're still collecting data for that to kind of go along those same, like, just sort of keep the same, I guess, structure convention.
What if
I mean, once it's done, we can convert all of them to numbers. But as I'm doing it right now, I don't know.
I wonder if there's any utility in adding in another config file that everybody fills out where it says what you coded it as, what you're using it as in the pipeline. So that's saved in there.
Right, or you could, I mean, in the way that it would be saved, if you just assign a new number, the way that information would be saved would be that because you would enter that information into the scanner folders, right? So you would enter your raw data containing that naming conversion inside the scanner folder. So you would say,
You've already converted it.
So, you think you're already converting it before putting it in here? Okay, so another way to.
We want to run this from scratch.
Yeah. And we wouldn't do that.
And so, I mean, I would say that if the way this is set up, it is expecting it to be like a number that iterates, right? There's an ID and then a number that's a specific number 1 to 1 with the subject. If it works that way, we might as well. You can collect it however you want.
Right.
But
Sure.
it should be analyzed in this way.
Sure.
I like your idea of doing like example 01 underscore. I would
Right.
do like
Yeah,
ACE1 underscore ACE9001,
Yeah.
right? So it's there, it's tagged, but it'll also work 1 to whatever.
Yeah, I think that works for all cases, right?
I think that with a little bit of work, you can undo that.
Sure.
But you're right that it's
I'll do it.
so.
Yeah.
You have like in terms of like what the subject IDs are on all the documents and everything.
Yeah.
Right.
It's going to be you're going to have some that are in one format. Some that are,
Right.
so that's what I'm saying. Like you can acquire it using the same format if you want.
Yeah.
And then
Just convert it at this stage.
right.
That's fine. Yeah.
Right, and even though you can put anything that you want in here, I think there is something to be said about keeping the subject IDs relatively simple because there is no really, I don't know, it's just for consistency, it doesn't make a lot of sense to have very complex subject ID names that contain too much information on them. If we need to keep that information, perhaps we should try to figure out where best to put it into. Jason was suggesting that we should have something like a scan info files inside these folders that contain anything that you want to know about that scanner acquisition, and perhaps we can do that as well for entering like a different type of label for that individual subject or something like that.
Alfonso, so just to clarify, is currently when it says sub example 01, is it expecting study name number?
Yes, it's expecting study name, number, and then anything else. That's the convention for, and the convention is specified here. It's subject ID, this portion in here, basically.
Okay, and it uses that, like it uses.
It uses that because when you specify something like example of one in the FL Basic import, in the syntax, it looks at this and it says, well, this is experiment example, and this is my subject example of one. So it knows what, in which particular folder to look for example of one. So it knows that it needs to go to this folder, and within there looks for this folder and things like that. So it uses that information, yes. I could make a different convention if you think there are good reasons to change that, to not use numbers or just something like that, but I don't know. You could always break it into something and then underscore something else. Like, I don't know. I think this is simple enough and it should work for pretty much all cases.
So for now, since we do have this sort of legacy naming issue, if we, for example, if I wanted to go through and put another config file in my subject that said what the original subject ID was, would the pipeline try to read anything? Or if I called it something that's not named in here, it would essentially just live in that folder?
Right. When you specify something like this, import example of one, the code actually looks for this. Looks for example config example of one. If it doesn't find, if it doesn't find it, it will complain. If there are other things in there that are not this, it doesn't care about it at all.
Oh, great. Okay, that's perfect. Then I'll probably just do that.
Okay. Okay, some additional steps that I didn't mention. So those three commands, basically FL Basic import, FL Basic preprocessing, and FL Basic first level, and are the basic three things that you will run. And the syntax is rather simple. Just specify the key for the subject and the pipelines and the first level analysis that you want to run. Sorry, you have a question?
Nope.
No.
It was just the line. Okay, but there is some additional things that you can run. So I just list them in here, like different scenarios that you might want to use in some other cases. So for example, if you just want to launch the con GUI to like kind of look at your subject in more detail, you can just use this FL Basic open and then the subject ID, and that will launch con, and it will launch that particular data. This will launch the raw data for that subject. So basically, this is the data that is stored in this location, right? The data that you just imported before preprocessing. If you want to do the same thing, but want to launch the GUI looking at the data after preprocessing, then use this syntax. You can use FL Basic open, then the subject ID, and then the preprocessing pipeline ID. And that will launch con with the GUI with the data that it has been preprocessed for you to look at in more detail, or to use the display capabilities in con to do anything else in there, or to do whatever you want from con, directly from the con GUI, right? If you want to do like an individual analysis on that. Then you can also do quality assurance plots like we had before. You can just use the syntax QA create, subject ID and pipeline ID for creating all of the quality assurance plots that are run after preprocessing. Basically, remember all of the normalization plots and co-registration plots, the movies for the functional data. All of those are created when you run the syntax. And then you can also run the QA plots for first level analysis, which creates the design metrics information display plot, also the one that looks at the contrast where they are estimable or not. And there is also a new plot that creates the first contrast, just a slice display of the contrast value for every subject that is created automatically as part of the quality assurance plots in here. And you create those quality assurance plots just using this syntax. If you want to look at the quality assurance plots for one particular subject, use this syntax. And if you want to look at quality assurance plots for every subject within one particular experiment, use this syntax. Then there are a couple of like corner cases that I thought might be useful. In some cases, let's say that you want to run preprocessing steps, but you want to run some additional preprocessing steps on top of the ones that you already run for one particular pipeline, because you want to run like an additional smoothing step and you don't want to repeat everything. You can do that using this syntax. You can append a second preprocessing pipeline to a first one. So if you already have to process your data in the M&A space pipeline and run that, you can just create another configuration file that contains the additional steps that you want to run, and use this syntax to run additional steps onto that already preprocessed data. Sorry, go ahead.
I was going to say, will that branch the...
Right, no, the branching is this syntax. This will actually create the output of that inside this same folder. So the output of this line will be stored within the derivatives M&I space folder, the same as it was in the original one, in the original preprocessed data. If you want to branch it instead, use this syntax. Basically, this will take your M&I space data and you run some additional steps, but it will create a different branch. Now you will have a derivatives other steps folder that contains that preprocessed data, and the original one will be kept untouched. Make sense?
Yes.
Okay. And then this is if you want to run it in parallel. By default, everything is running locally just because it's simpler and because it's, at least at the beginning, I think it's more error-free. It's easier to detect errors when you run things locally. But if you want to run things parallel, you're already confident that everything is running without errors and you just want to parallelize things, just use the syntax, add the parallel one fields to your preprocessing FLBasic command, and then we'll run it in parallel into the cluster. And when you run it in parallel, you can use this syntax to check how things are going. If you want to check the status of the jobs that you submit, use this. If you want to actually delete those because they run into a problem or because they are taking forever, use this syntax for that. That is it. And then those are these things at the bottom are the things that I already mentioned. The syntax when you want to run multiple subjects simultaneously. If you want to run all of the subjects that you create simultaneously and run import for all of them or preprocessing for all of them, you can do that using this syntax.
Is there a parallel processing for the first level analysis?
Not yet, right. That is something that will happen soon, but it's not yet there. First level analysis are relatively fast, so they should take only a couple of minutes or so. So that's why it hasn't been too much pressure on me to actually create that parallelization option into the first level analysis. But yeah, it will happen soon. Currently, it's only part of preprocessing.
Is there any significance to the parallel one? Is that using?
Oh no, the parallel. No, sorry. The one is just because there is a. You could specify the different number of processes that you want to branch it into, but it's only a single subject always, so there is no point of trying to break it into more than one process. So. Okay. Okay. Any questions before I go into the details of the configuration files? Then, just briefly. Okay, and the configuration file. So, okay, so what we have right now is basically basically when you create a new experiment, you enter all that information here, and when you add new subjects, you enter that, and then you run these FLBasic commands to actually run the preprocessing steps and first level analysis and quality assurance plots and all of these things on your data. So the only thing that kind of like we haven't gone into details, in part because we look at that in a little bit more detail when we look at the FL scripts, is what is the actual format of these configuration files that you have to create to specify all of the information about your experiment and about your data. So I'll go briefly with all of the options in here. Here it tells you all of the details about all of the different options. So we have four types of configuration files that you can create. The first one is the one that you specify for every subject and contains basically where your data is located and what is the experimental design for the functional runs for that particular subject. And the way you enter it is by specifying these fields, the functional, structural fields, DICOMs, if you have DICOMs, then the TR, the design runs and design files is where you specify the actual experimental design for every functional run that you have defined here above. Then if you have unword functionals, you specify them using this field. All of these configuration files have the same format. You specify field names and then field values. Field names start with this hash command, and they are followed by the actual values of that. So an example of a file like this will be something like, let me see, I have an example here. Example of one configuration file. This is where you specify the functional data. This is where you specify the TR for that data. This is the structural data. These are the functional runs that you want to enter, that you want to use as functional runs into your first level analysis, and these are the actual experimental design for those four functional runs. This is all what an example of one configuration file looks like for a given subject. And in here, it gives you more details about what to do when you have nifty inputs and what to do when you have nifty DICOM inputs and things like that, whether you can specify things using the full path or partial paths. All of that information is specified in the little detail in here, so I won't go into the details. But you can read in here the documentation. It's also in the help of the FL function. Okay, and then the design information files, those are where you specify the condition onsets and durations. And we already talked about most of that before, but not all of that. So I'll go briefly about the additional options in here. You have the condition onsets and durations that you, a typical example looks like this. Let me see if I can show you. There's a long list of numbers. Yeah, something like that. So just specify that I'm going to enter every time information in units of scans. You can use either seconds or scans. If you specify in scans, the first column of the onset is scan number. If you specify the units in second, then the first column of the onset field is actually the second, specifying in seconds, the time of each event in seconds. And then the onset is always an n by 2 matrix. N is the number of events that you have, or conditions, or the events that happen, or blocks that you might have in your experimental design. And this is the condition onset, and this is the condition number, basically, a number that goes from 1 to whatever number of conditions you have. Here's where you just provide the condition names. So the numbers in the second column go here from 1 to 3. So you have 3 conditions, and those are the 3 conditions names that you are specifying in here. And then this specify the duration for each condition. You can specify this as a vector of 3 numbers if you have 3 conditions, if the durations are basically the same for every condition. And if the durations are different for every event, you can also specify it as a long column vector instead of a row vector with the actual durations for each individual event in that case. Okay, so that's what goes into the design information, and there are a couple of additional things that go in addition. This is how you specify the typical onset duration information. Then we have 3 additional options to specify different types of modulation, what we call either parametric modulation or non-parametric modulation. I don't know if you're familiar with parametric modulation in SPM, probably some of you are already. Parametric modulation is where you specify for every event, you have a number associated with it, which might be something like a response time, for example, and you want to study the association between the ball signal level, the activation, and that number, basically the response time, whether the activation is higher for the longer response times and lower for the shorter response times, or vice versa. So that's how do you actually do that. You do that in SPM, at least, using what is called parametric modulation, and you have to specify for each event that those numbers, and then you have to specify that you want to run a parametric modulation analysis. And the way you do that in our scripts is by entering these PMOD fields. You can specify a PMOD field that specify for every, let me see, this is where condition N is modulated by covariate K. So if you have a single, let's say you have something like response time, you can enter a PMOD will be, and you have 3 conditions, you will enter just a single row with 3 numbers, and what you are entering those numbers are just ones and zeros, and it's specifying whether that particular condition is to be modulated by that particular covariate. So you are going to have a covariate that is response time, and you just have to specify to which covariate to which condition or conditions do you want that covariate to modulate. Do you want that covariate to modulate only one given condition? You just enter like a 1, 0, 0 to specify that you want that covariate to modulate the first condition. If you want that covariate to modulate all 3 conditions, you will enter like 1, 1, 1 to specify that you want that covariate to modulate all 3 conditions. And if you have multiple covariates, you can also enter multiple rows in that. So you could have like 2 covariates, one response time and one, I don't know, like a hand movement. And then you could
I know, I thought that was really stressing me out too. Oh no, that means he's too. Doesn't stress me.
We'll just close this.
Monster doesn't care about that. Well, I'm so scared.
I let it ride until it's 1%.
That's so scary.
I live on the edge.
Yeah.
Yeah.
It really stresses me out when your protagonist doesn't care that the gas lights are on.
Also don't care about that.
My dad.
Oh, well, that feels.
Been stranded at least 3 or 4 times.
Oh, see, I've never.
Was stranded? No, my dad actually goes all the way to the bitter end.
Oh,
Yeah. If I know that if I've gone 40 miles since the flight came on, I should probably get some gas.
It's 100 kilometers. You can go under like
Just this whole
You
conversation.
can go up to
I know, right?
65.
Like,
I know, but at 40, that's where I draw my line.
I have to run.
Yeah.
I have to run.
Okay.
Do you want to be in charge of figuring this out? One thing I've noticed is that if we end there we go. Told you. If we end recording here, I think we have to do a new meeting to record
I
again.
think we had a good stopping place though. To try it.
Yeah,
Yeah,
I think
so-
there were a few
Rearrange
more
some of the
things to
things
discuss,
that
but
we
Is that?
that's from
that's it?
before.
Oh,
That's
okay.
from before.
That's what
But I don't know if you just want to, if you can reach out to him. But I'm
Yeah.
on a hard deadline here. So when you leave, log out of that and just process the recording.
Yep.
Don't steal anything.
Okay.
All right. Okay. I'll get feedback from you tomorrow.
Yeah,
Or
I
later.
just when that was the paper, I can also add based on the last paper that I shared.
Okay.
So I can write a bit more there and I'll do the amendments
Or results.
for other results. Yeah.
Yeah, from that one. Yep. Excellent. All right,
And
guys.
actually, with the baseball game, the group tickets are much more expensive. So I'll go get us to 12. So,
All right.
Anyone wants to apply? Catch you guys later.
see you later.
Just keep that open. in case.
Oh.